says it's not recording yet. So I'm just... Electrolytes. I think these are actually pretty interesting. I'm sure when you hear the word electrolytes, the first thing you think of is Gatorade, due to a very successful decades-long marketing campaign. But I also think you probably have no idea what electrolytes actually are. So that's what we're going to talk about today. By the way, if you're following along in your purple book, I'm going to be skipping around in this video. Right now, we're on page 65. You can pause the video while you go find that page. Did you know that? Anyway, this is on page 65. I'll tell you, purple book people, what I'm skipping around to. So anyway, electrolytes are compounds that conduct an electric current when they are dissolved in aqueous solutions. Ionic compounds will dissolve in water, and so they are electrolytes. Covalent compounds are not electrolytes. And the biggest reason for this is that even though some covalent compounds will dissolve in water, they don't have positives and negatives the way that ionic compounds do. When an ionic compound dissolves in water, it dissociates or separates to produce charged particles that can carry an electric current. Did you know that's what an electric current is? Like when you turn on a light switch, the thing that makes electricity work is that the wires in your walls are made out of metal, usually like copper wiring. And then there's like electrons moving through the wire. And that movement of charged particles, those electrons have a negative charge, right? So the movement of charged particles is actually what creates the electric current that goes through the wires to your light bulb and then turns the light on or charges your phone or like whatever you're doing with the electricity. Those charged particles carry an electric current. It doesn't have to be negative electrons. That's just what works the best in copper wiring, and it's like real easy to like deal with. But if you have an ionic compound, it can also dissolve in water to make like separate charges. They separate into positives and negatives, and those positives and negative ions also can carry an electric current. So electrolytes will light up a light bulb. You can dissolve salt into water, and salt water will conduct electricity. This is why your Pikachu will always wreck a Squirtle, okay? Because the water, salt water, conducts electricity, and then you hit him with a thunderbolt, and like, you just fry the poor Squirtle. Anyway, sorry, my daughter's watching a lot of Pokemon lately. I'm not sorry. You know I'm not sorry. Anyway, non-electrolytes are compounds that do not conduct an electric current in aqueous solutions. They may dissolve in water, but because they are covalent compounds in general, they don't have positives and negatives to conduct electricity. So you can dissolve sugar into water, but it's not going to conduct electricity. Covalent compounds do not dissociate into ions in water, so they do not form charged particles. And if there are no charged particles, then they cannot and do not carry an electric current. Non-electrolytes then will not light up a light bulb. Sugar water, not going to conduct anything. Salt water, though, your Magikarp better watch out. Gatorade. The reason you have electrolytes in sports drinks like Gatorade, Powerade, whatever, is because your body actually runs off electrochemistry. The way your nerves in your body run and like the way your thoughts in your brain work is that there's actually electric currents that get passed along your neurons and through like the axons, and like you can look up a diagram. Anyway, the water in your bloodstream and like your cranial fluid and stuff like that has a bunch of dissolved ions in it, like sodium and potassium. And those charged particles are actually part of what moves to help the electricity in your brain, that is your thoughts, move to the rest of your body to tell your body what to do. If you've ever watched The Matrix, the robots like actually use human bodies as batteries, which would be like a super inefficient system. They should have just cleaned up the earth and used solar power. But it you have to have electrolytes to conduct that electricity. When you sweat, if you've ever like gotten really sweaty and sweat's like dripped into your mouth, it tastes like super salty. When you sweat, the reason it's salty is because while the water's coming out of your sweat glands, so are the electrolytes, like the sodium and the potassium ions. And so when you are sweating a whole bunch, you're losing not just water, but also those electrolytes. And then when there's fewer electrolytes in your body cannot conduct electric current. So like your thoughts can't get to the rest of your body as well. If you've ever seen those compilation videos of marathon runners collapsing, what marathon runners and triathletes who have been doing it for a while know to do is they actually have like salt pills in like little packets, and they'll like zip it into a pocket or whatever. And then they'll just like tear the packet open right before they get to a water station. They'll like toss the salt pill. It's literally just a pill made out of salt. And then they like swallow it back, and that's the quickest way they can get some electrolytes in there. So their body can keep making the electric signals work from their brain to the rest of their body. If you sweat too much and you don't put electrolytes back in, your body literally cannot listen to your brain anymore because there's not enough to conduct the electric current. That's also why sometimes if you see like post-game interviews with athletes, they sound like the stupidest people you've ever heard talking. And they're probably not actually that dumb. It's probably that they're missing electrolytes so much because they've been sweating so much that they literally cannot think as well right now until they get more electrolytes back in their body. So this is why like it won't like hurt you to drink Gatorade or Powerade if you have not been sweating. Your body will just like make you pee out all the extra electrolytes. But if you have been sweating, just water is not going to be enough. You've got to also put electrolytes back in your body, or your body's not going to be able to like conduct the signals it needs to. So Gatorade, Powerade, those are like really easy ways to put the electrolytes back in your body. And that's why those drinks have been so successful. Let's also talk about concentration. I've moved on now to page 67. This is part of page 67, if you're in the purple book. Concentration is a measure of the amount of solute per given amount of solvent or solution. It's basically a proportion. So it's measured in units of molarity, where a concentrated solution will have a big ratio of lots of stuff dissolved into not as much total other stuff. Where a dilute solution, there's going to be a very small fraction of stuff dissolved in, and most of it is going to be water or solvent. So like a concentrated solution, if you've ever heard of like orange juice from concentrate, right? They sell those little like canisters in the frozen aisle. My parents buy lime concentrate and they make margaritas out of it, which is like the easiest way to do it. It's not necessarily the tastiest. But anyway, concentrate, fruit juice concentrate, what they do is they like go get the fruit, like they'll get a truck full of oranges and they'll just dump the entire like thing of oranges into this big machine, and they'll just grind it all up and mix it. And it's like everything. There's like peel and the seeds, and they just grind it into this like pulpy powder. There's probably bugs in there. And then they like freeze it in little cylinders or little, sometimes like bricks. And they just freeze it like that. And then when you have juice from concentrate, what that means is they took one of those little frozen bricks, they thawed it out, they mixed it with water, and then they diluted it. So they had like 100% orange from that like brick, except maybe like 0.5% bug or whatever, but it's like 100% ish fruit. And then they add a whole bunch of water, and they dilute it, and then you have like juice from concentrate, where it's like, now it's like 5% fruit or 20%, I don't know, like it depends on the brand you buy. And then pretend I know how to draw a juice carton. There. That's an orange. And the rest of it's water that they just added later. That's what from concentrate juice is, where they had like a huge percentage of orange and then they like froze it like that. And then later they thawed it, watered it down, poured it into a bottle and sold it to you. A saturated solution contains the most solute that will dissolve in a given amount of solvent at a given temperature. Like you can dissolve more stuff if your water is hotter. But at whatever temperature, there is like a maximum amount that fits, right? Like if you've ever tried to gone to like somewhere that gives you unsweet tea and you have to add your own sugar, but the tea is already iced, you can never add enough sugar to make it as sweet tea. And the reason for that is sweet tea, if you've ever like worked in a restaurant and you had to make the sweet tea, they like brew a whole bunch of tea at once in like a giant container, and they dump like a whole bag of sugar in there while it's still hot. And then they stir it up and dissolve it, and then they ice it down and serve it to you. Because you can mix way more sugar in while it's hot to saturate the solution. But if it's cold, then you won't be able to add as much sugar, and you'll only be able to add like 2 packets of sugar or something, and then you just have grains of sugar floating around in your crunchy tea, and it's terrible. You just can't add as much. It won't all dissolve. It just sinks to the bottom because the solution is saturated. It's as full as it can get for the temperature that it's at. If you have an unsaturated solution, more solutes can still be dissolved. Next, I'm moving to Purple Book, page 68. This is at the bottom of page 68 to talk about precipitation reactions. This is mostly just vocabulary. A precipitation reaction is a reaction in which the ions in separate solutions are mixed together to form an ionic compound that settles out of the solution as a precipitate. So the dissolved ions first like end up finding each other. Like you have one solution with dissolved ions and a different one with dissolved ions. You pour them together and then they find each other in there and they bond and they will settle out as a solid or a precipitate. A precipitate is an insoluble product. Insoluble means that it can't dissolve. Insoluble means it is not soluble. It can't dissolve in water. So a precipitate is a solid. It is insoluble. So there's a little vocabulary chart for you. Does it dissolve in water? No, then it is insoluble. It's a precipitate. It's a solid. Does it dissolve in water? Yes, then it is soluble. It dissolved. It is aqueous. Those are some vocabulary words for you. And the final thing I'm going to talk about in this video is skipping ahead to page 71 if you're in the Purple Book, talking about dilute versus concentrated solutions. A dilute solution is one that contains only a low concentration of solute, meaning there is not very much solute compared to the overall size of the total solution. It's like a low percentage, whereas a concentrated solution contains a large concentration, or you could say a large ratio or proportion of solute. So there is a large amount of solute compared to the overall size of the total solution. So like a dilute solution is a small percentage of stuff, or solute, but stuff, and a large percentage of water. Whereas a concentrated solution is a higher percent of solute stuff in a low percent of water. When you make a dilution, you can make a solution less concentrated by diluting it with more solvent, which is usually water. So, and I'm actually going to skip this last bullet here, but you can make a solution less concentrated by diluting it with more solvent, with more water. Basically, if you have a small proportion of of water with like way more stuff mixed in it for how much water there is. If you want to dilute it, you just add water to it. This is also something you do with like little kids and like juice, right? Like if you give them apple juice straight out of the bottle to like a 2-year-old, it's like way too much sugar for that tiny little body. And then they like go absolutely feral and they're like running all over your house and like kicking stuff over and screaming for an hour. And then they get really constipated. So instead what you do is you pour like a little bit of apple juice in their sippy cup, you fill it the rest of the way with water. They think they're getting a whole cup of apple juice, but it's really like this much apple juice and the rest of it's water because you dilute it. And then they don't go feral and they also don't have trouble pooping later, which is its own problem with little kids. Anyway, that's dilution. The end. On that note.